Welcome back, everybody. This week we're going to be learning about the unit circle, and we're just going to be learning about it in degrees. So if you Google things about the unit circle, you'll see a lot of them with different measurements. Today we're going to focus on degrees. Next week we're going to actually get into radians. So what I have for you here is a picture of the unit circle. And one of the things on it is the unit circle. It's a circle on an XY axis. So, we have X and Y, and then it has a radius of 1. So every line on this circle has a radius of 1. Okay? The way that it works is basically, it's going to be kind of weird to show. Let me try. So everything's going to start from right where I drew that radius. That would be 0 degrees. And then what we do actually is we work our way up and around counterclockwise from here. So if we go all the way up to the top, that is 90 degrees. And I hope you guys can see that the x-axis and the y-axis, the two positive parts, make an angle of 90 degrees. And then again, if we keep going, this would be 180 degrees, which should make sense because from 0 to 180 is a completely flat line. As we continue going around, down here is 270 degrees. And then back to where we started, that would be all the way around the circle once, which I hope you guys remember from, I think, elementary school, probably, maybe middle school, is 360 degrees all the way around a circle. So that is where those basic measurements are. We can break that down even further as we go. So from 0 to 90 degrees, if we went right exactly halfway between them, which would be, this point right here, if you can see, let me see if I can highlight that if it look better, right there. That is exactly halfway between 0 and 90 degrees, which is 45 degrees. And then we can continue on filling out the rest of the unit circle. There are pictures of unit circles all online for you to look at if you want. Again, we're dealing with just degrees right now, so make sure you're only focused on degrees. Hopefully you can see, and I'm going to do some highlighting here, that if we take this section, and this section, what we've done is we've divided up 90 degrees into 3 equal parts. So the point between the green and the yellow must be 30 degrees, and the point between the green and the blue is 60 degrees. Okay. As you noticed, hopefully, the blue segment I drew, each of those is 30 degrees. So if we continued it right here to find this next value of this next point, okay, 90 plus another 30 degrees would give me 120 degrees. And then again, if we look back into quadrant 1, remember these are labeled quadrant 1, 2 is the negative x positive y, 3 is negative x negative y, and quadrant 4 is if we have positive x values, negative y values. So if we look back into quadrant 1 between the 60 and 45, that's a difference of 15 degrees. So 120 plus another 15 would give me 130 degrees. And then plus another 15 would give me 150 degrees. And just make sure that from 150, this segment here, to 180, that is indeed 30 degrees like it should be. So we're doing good. We continue along the process. If you want to pause and try to fill in the rest of the numbers, that would be a great thing to do. Feel free. Okay, this is what you should have if you continued filling it out. Again, we're going to get into radians next week for this. What I would like to do next is I kind of want to clean up some of the things. So I am going to, I think I'm going to get rid of my highlighted portion if I can. Okay, so getting rid of my highlighted portion first. And then I think what I am going to do is get rid of the dotted line. Okay. What I want to do here is I want to add in kind of what the coordinate points would be. And we're not going to have all of them right now. We can, but what we're going to do first, just if we have this point right here, remember the radius is 1. To get to that point, I went to the right 1 space and I didn't go up or down. So that would be 1, 0. Similarly, the point up here, I didn't go left or right. So that would be 0, I went straight up 1 whole radius of the circle, which is 1. Over here from the origin, I went left 1, so that would be a negative 1, 0. And down at the bottom, I didn't go left or right, and I went down 1, so 0, negative 1. This kind of gets into, hopefully you know how to graph by now, you are in Math 3, but this gets into our positives and negatives, depending on which quadrant we're in. I'm going to kind of tell you a trick for things. Hopefully you guys remember it from this. These are which trig values are positive in which quadrant. Up here, this is, oh, that's way too thick. Hold on. I don't even know if you saw that. This is all trig values are positive. This is only sine would be positive. And then down here, we have tangent would be positive, and over here we have our cosine values would be positive. The way that my teacher taught me this when I was taking this class in high school myself, you remember that the quadrants are numbered from counterclockwise from quadrant 1 and then 2, 3, and 4. So similarly, using the acronym of the trig functions, A, S, T, and then C, he described it as all students take calculus, and that's still to this day how I remember which ones are positive in which position. If you are drawing the triangles and you are aware, you know, that negative x's are over here, negative y's are down here, everything else, you know, up here is positive y, over here is positive x, you should be fine. But just as a little trick to help you remember, whichever quadrant you're in, either quadrant 1, they all should be positive. Quadrant 2, sine is positive. 3, tangent is positive. Cosine in quadrant 4 is positive. So let's actually now start making some triangles in this and then solving so you can actually see what we're using this for. All right, the first problem we're going to do is we're going to need to find tangent of 150, so 150 degrees. And if you remember from the unit circle we had, 150 degrees was right over here. Okay, so what I'm going to sorry about that, I'm actually going to draw in my triangle at 150. And the way that's going to look, you're going to kind of just drop it down from the point of 150. The straight line on the triangle is going to be the bottom of it. And then the line that's going from the center to the 150, that is going to be our hypotenuse. So no matter which line that you're on, so let's say you needed, I don't know, the one up here. Let's say you're at 120. If you were to do that triangle, you would draw it like this. Drop it straight down to the x-axis from the center to the edge of the circle. That's your radius. And for example, that's what a 120-degree triangle would look like. I'm going to erase that one off of here, and then we are going to get going with the 150. Okay, so I'm going to redraw the parts that I accidentally erased off. Okay, so we need to find tangent of 150. That means my theta is going to be right here at the center of the circle, and that's where it's always going to be. And then what I'm going to now need to do is figure out the values of all the other sides of my triangle. So what I'm going to do, just to kind of help it hopefully not be a bit messy, I'm going to label my opposite, hypotenuse, and adjacent on the circle, and then I'm going to redraw the triangle so I can do my working out. So my hypotenuse is always going to be the one across from the right angle. My opposite of theta is the one over here, and my adjacent is the one right next to it. So I am going to redraw this triangle, and I'm going to keep it oriented how it is on the circle. Keep my theta down there. Remember the hypotenuse, it goes all the way from the center of the circle to the edge of the circle. That means it is a radius. In a unit circle, the radius is always 1. Okay? So that is why last week I made sure you guys always had the hypotenuse equal to 1. Hopefully you can see how this is kind of drawn. This is a 30, 60, 90 triangle, which is also why we did lots of practice with that last week. So for a 30, 60, 90 triangle, what I am going to have across from 30 degrees, that is A. Across from the 60 degrees is A times root 3. And across, the hypotenuse, that is 2A. If you remember from last week when we solved these, our A ended up being 1/2, right? Because 1 equals 2 times A. That means A is 1/2. So what I'm going to do is I'm going to rewrite this A as 1/2. And I'm going to rewrite this as 1/2 times root 3, which is root 3 over 2. Now I am ready to find the tangent of this theta of this triangle. But there is one small, well, kind of small, but important thing that we need to recognize. This value right here, let me highlight this. This leg of the triangle, right? From the origin, it's going to the left. That means that it's on the x-axis and it's going left, means it's negative. So what I need to do is I need to make this leg a negative value. So I am going to make that a negative root 3 over 2. Okay, and that is why if you remember for the all students take calculus, this quadrant, sine should be the only thing that is positive. And you can kind of see that on this triangle. If we did sine, opposite, and hypotenuse, both of those values are positive. Everything else uses adjacent, which in this case, like we just said, is that yellow highlighted part. That's negative. Okay, so just try to keep that in mind. If not, just remember that all students take calculus and adjust your final answers as needed. So tangent of 150 degrees, that is going to be my opposite over my adjacent. And opposite in this problem is 1/2. And it's going to be over my adjacent, which is that negative root 3 over 2. This is why we practiced this last week, a complex fraction. It's going to end up being 1/2 times negative 2 over root 3. We have some canceling going on. I get a negative 1 over root 3. We cannot have a radical in the bottom, so I'm going to rationalize it, multiply the top and bottom by root 3. And I end up with the tangent of 150 degrees is negative root 3 over 3. I know, quite a few steps. Main thing is you want to draw the triangle into the into the circle. Label opposite, adjacent, hypotenuse. Label it out with our special right triangles that we did last week. Feel free to use those notes with you this week if you still have them. Plug in the values and then just solve from there. The math itself isn't any more complicated than it was last week. The only tricky thing is figuring out what to label everything. So please do be careful of that. All right, example number 2, find cosecant of 120. If you guys want to pause it and at least get your triangles drawn out right now, please do so. Remember, we are at 120, which is the measurement right there. So go ahead and get your triangle drawn and then hopefully label everything with your adjacent, hypotenuse, and opposite, and then with the values from the special triangle as well. Okay, hopefully your triangles look like this. I labeled the A 2A and A root 3 on the unit circle so it wouldn't get too confusing on the other one. Again, the hypotenuse is 1 because it is a unit circle. So the hypotenuse is always, 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 always equal to 1. And hopefully we've done enough examples of this that you know that if we're in a 30, 60, 90 and the hypotenuse is 1, that means A is a half. So I went ahead and I labeled my adjacent as negative half because again, remember we are right here along the x-axis going left. That means it is negative. And then I labeled my opposite root 3 over 2. So what we're going to do now to solve, so let's get our just general, thing written down. We have cosecant of theta. Remember, it is the reciprocal of sine. So sine is opposite over hypotenuse. That means this has to be the hypotenuse over the opposite. And then I am just going to plug in all the values that I have. So I'm going to have cosecant instead of theta, we're going to say 120 degrees. And that equals my hypotenuse, which I look right here, is 1. So 1 over my opposite, which is right here, because remember opposite's over there. That is going to be root 3 over 2. Again, a complex fraction. This is why we did so many practice problems with them, so you can get used to how to do this, hopefully quickly. Okay, I'm going to pause this and let you guys see if you guys can do it, and then come back and check your answer. And this is what you should have as your final answer. Remember the denominator, so when we are right here, the denominator flips up to the top and multiplies with 1, so it just becomes 2 over root 3. I had to rationalize that with my multiplying by root 3 over root 3, and then I end up with the cosecant of 120 degrees equals 2 times root 3 over 3. Okay, we're going to do one more example. And then I'm just going to talk about some special cases. So like what do we do if we have sine of 90 degrees or tangent of 270? How do we draw those triangles? So one more example for you guys to do on your own. All right, I would like you guys to find the sine of 330 degrees. I'd like you to ideally do this one all on your own or as far as you can. Before you push play again. So pause the video, please. Go ahead, start to solve this. It is sine of 330 degrees. All right. Okay, just a midway check. This is what you should have labeled on your triangle. Notice that for this one, our y value right here is actually negative because from the origin, you know, for the adjacent, we went right, which is positive, but then we went down, which is negative on the y value. So I had to make this value, my 1/2, a negative. Okay, go ahead and pause again if you hadn't finished, or if you just had the wrong numbers and want to now retry it with these correct numbers. And then when you come back, the answer will be here. All right, this one was pretty straightforward. We didn't even need any radicals in this one, so it just ends up being a negative 1/2. So sine of 330 degrees is negative 1/2. What I want to talk about really quick with you guys is what if we have something like sine of 90 degrees? On a lot of them, like I told you guys, when we are drawing the triangle, we take the point we're talking about and we drop it down. And then that's our triangle. Well, if we're going all the way up to 90 degrees, kind of just watch how this moves along. As I get closer and closer to 90, notice the triangles are getting, you know, skinnier and skinnier and taller. And as I get all the way, almost super close to 90, so it's really close to 90. And this value that was right here, if you looked along all of these, this was always our hypotenuse. So this side right here is the hypotenuse. If you look at this vertical piece, this was always the opposite. So that means this really tall one over here is the opposite. And look at what's been happening. Down here's been our adjacent. And what has been happening to it every time? It's been getting smaller and smaller and smaller. I hope you can see that. It's in yellow. So the adjacent is way down there. So as we get up to 90 degrees, it's almost like our adjacent completely just disappears. So if I wanted sine of 90 degrees, I'd have to do the opposite over the hypotenuse. And if we're at 90 degrees, they're basically both the radius of the circle, which means it's 1. So sine of 90 degrees would be 1. And if you want to type that into your calculator right now, you will see that when you type in sine of 90 degrees, you should get a value of 1. The only time you might not get a value of 1 is if your calculator is in radians, and we're going to get into that next week. Similarly, if we wanted cosine of 90 degrees, let's think about this. Cosine is the adjacent over the hypotenuse. So our adjacent basically went to 0, and our hypotenuse is now a radius of a circle, which is 1. So 0 divided by 1, that is 0. So cosine of 90 degrees is 0. Let's talk about what if we needed 180 degrees. So what if I needed sine of 180 degrees? What would that look like? Well, if we go back to drawing the triangles again, as we get closer and closer to 180 degrees, our triangles are getting like flatter and flatter. The other ones are getting really tall and skinny. These are getting flatter and flatter and flatter. And as we get super, 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 super close, we notice that this value, the height of our triangles, right? That was our opposite. Our opposite is basically going to 0. And in this case, our hypotenuse is becoming just 1 on the, the radius. And then our adjacent is now also becoming 1 on the radius. So sine again is opposite over hypotenuse. And if we're at 180, my opposite right here, this opposite's 0. He's basically gone. My hypotenuse is a radius, so 1. That means sine of 180 degrees is 0. What if I needed to do cosine of 180 degrees? Again, cosine is adjacent over hypotenuse. And as you see, both of those got smushed down to be just the radius. So 1 over 1, which is 1. Now it gets interesting if we want the cosecant of 180 degrees. So cosecant, remember that's the reciprocal of sine. So hypotenuse over opposite, which in this case would be 1 over 0. What's anything divided by 0, you guys? It's undefined. Okay, and there is actually one minor thing that I forgot about on this. I'm going to let you pause it and see if you can find what I messed up on real quick. Okay, curious how many of you guys found it. Tell me in your bookwork today if you caught the mistake. Right here when we're at 180, I'm going to use the highlighter for this one. Our adjacent is negative. So I actually should have made the adjacent a -1, which means that cosine of 180 is -1. Now check that on your calculator. It should be. Sine is still positive because remember, all students take calculus. So sine is still going to be positive up there, and so is cosecant because it's just the reciprocal. So it just flips the numerator and denominator. Plus, we can't really have an undefined negative. So that's kind of what happens as we get really, really close to the edge. What I would like you guys to try to do is find out what tangent of 270 degrees is. So try to draw your little triangles, try to visualize what tangent of 270 degrees would be. And then I would also like you to do, I don't know, let's do sine of 270 degrees as well. So do both of those and then come back. Okay, so I drew in some of the triangles and I did this one in pink. I know it's getting a bit messy. So I did this one in pink and I noticed as I got closer and closer and closer to that 270 mark down at the bottom, my adjacent was getting smaller and smaller and smaller. So my adjacent basically goes to 0. The opposite is a -1 because, again, I'm going down. Okay, so -1 and the hypotenuse is still a +1. So what happens is I get tangent is a -1 over 0, which ends up being undefined. And then sine is opposite over hypotenuse. So a -1 over a +1, and I get a -1 for my answer. So what you guys are going to do now, you are going to do the bookwork. What are we on? 7.4, I think. Then you guys will have a classwork tomorrow, Zoom check-in, and any questions on Wednesday, and then the mini test on Thursday. Next week, we're basically going to be doing all of this, except for instead of degrees, we will be doing radians. I hope this made sense for you guys. I know, like, if you look at the final video or if you fast forwarded, it's really, really messy, but I hope you were able to understand what I was saying verbally and that this kind of makes sense to you guys. If not, please let me know. Please come to the Zoom check-in with your questions. All right, have a good day, you guys.